Hello everybody, Mr. Longo is back again with Unit 4, and this is the unit that covered graphing rational functions and then also working with rational functions. So to start out, we're going to remind you on vertical asymptotes is always when you set the denominator equal to 0. So if we set x minus 5 equal to 0, we are going to get x equals 5. And yes, before you ask, you must have the x equals in front. If you wrote a 5 on a quiz or a test, you lost points because 5 is just a number. X equals 5 is a vertical line. So we would need a vertical asymptote at x equals 5 on our graph. Horizontal asymptotes. This is where we have multiple rules. But one of the rules is if there's a number off to the side, that's your horizontal asymptote. So we're just going to go with y equals 3. And we're done. Domain. Remember, domain is always x cannot equal any vertical asymptote or hole. But there's no hole for this one because nothing canceled. Range is y cannot equal any horizontal asymptote or y coordinate of a hole. Now, to graph this, all you need to do is type it into your graphing calculator and get a nice pretty picture. Just remember to type things in correctly. So if you have a really nice calculator with the fraction feature, you can just type that in exactly how you see it. But if you don't, remember you need parentheses around the fraction and parentheses around the denominator. So that would be parentheses 2 divided by, your denominator has multiple parts. Close your parentheses for the fraction, then add your 3. If you do not type it in correctly, you're going to get the wrong answer. It's not the calculator's fault, it's your fault for not typing it in right. Again, vertical asymptotes is always what makes the denominator equal to 0. Horizontal asymptotes. This is an example where we have y equals 3. Now remember, the horizontal asymptote we get if there's x's of the same exponent on top and bottom. So we have x to the first, x to the first. If you have the same number of x's on top and bottom, it is the ratio of the leading coefficients. So 3 over 1 is going to give us 3. Okay, so that's how we get those. Remember, there was a video earlier in this semester that covered it exactly. Make sure you know all those properties. So x cannot equal a negative 2 and y cannot equal a 3. There was no hole because nothing canceled. So again, go to your graphing calculator, type it in, get a nice pretty little sketch, and we're good to go. But number 3 is where we add some fun with a hole. So, common mistake that people made, first of all, you have to factor, and you must factor correctly. If you factor it wrong, obviously your graph is going to be wrong when you're done. So make sure you factor things correctly. Now, this is the mistake people made. People said there's a vertical asymptote at x equals a negative 6 and x equals negative 4, and you are very wrong. If you actually typed it in the calculator, you would notice there's no asymptote at x equals negative 4 because the negative 4's cancel. Remember, you do not list asymptotes until after you simplify your expression. So, what cancels, remember, is very important. You set the x plus 4 equal to 0 and you get x equals negative 4. That is the x coordinate of your hole. Now, our vertical asymptote is x equals a negative 6 because we only set the denominator equal to 0 for our simplified equation. And then we have the same number of x's on top and bottom, so that means it's y is equal to 1 because the leading coefficients are 1 over 1. Now, as far as the hole goes, the hole, after you get the negative 4, you need to plug it into your simplified equation. So negative 4 minus 2 over a negative 4 plus 6. So that's going to give you a negative 6 over 2, so obviously it's a negative 3. And then we go to negative 4, negative 3, and we put a hole there. Now, as mentioned before, that some of you ignored, the graph must go through the hole. If your graph is not going through that hole, then you probably typed it in the calculator wrong. Okay? So that's it. And also remember, you will never have an asymptote going through the hole. The hole is totally different from asymptotes. Now your domain is x cannot equal the -6 or the -4. It is x cannot equal any vertical asymptote or x-coordinate of the hole. And same with the range. Y cannot equal any horizontal asymptote or y-coordinate of the hole. Okay? So that's graphing. Let's go talk about some other stuff. Least common denominator. So to do that, you obviously need to be factored first. So this would be an x minus 2 and an x plus 1. This guy is just x minus 2. So you need to have what's missing. So this would need to be multiplied by an x plus 1 on the top and bottom. But we don't need to simplify this one because all it asked us to do is list our least common denominator. That would be an x minus 2 and an x plus 1. Okay? Least common, not just a common one. Least common. So, when we work with adding, subtracting, multiplying, dividing complex fractions, the first thing we always have to do, of course, is factor. But when it's dividing, we need to flip the fraction that comes after. So this is x minus 5 over 1, if it makes you feel comfortable to put a denominator. Then we're going to factor this by the difference of two squares, giving us by x plus 4 and an x minus 4. But notice we wrote it on the top now because this division flips the fraction. This is going to give us an x minus 5 and an x minus 4. And now is when we can start canceling. So these x minus 5s cancel, these x minus 4s cancel, and we finish with just x plus 4 over 1. So we can just write x plus 4. And number 6, whenever you are adding and subtracting, you of course need to factor first. So this is an x plus 3 and an x plus 3. This guy has an x plus 3 and an x minus 3. So you need to have a common denominator. And it's the least common denominator. So this one has two x plus 3s. This one has an x plus 3 and an x minus 3. So this side needs... This one needs another x plus 3, and this side needs an x minus 3. But don't forget, you must write that on the top and bottom. So, we just continue working from here. This side needs to be multiplied. So, that's just going to simplify to 2x squared minus x minus 15 after you multiply plus... And then we need to distribute the x, giving you x squared minus 3x. Of course, we're going to combine all of our like terms. So that would give us 3x squared plus 2x minus 15 all over our common denominator of an x plus 3 quantity squared and an x minus 3. Yes, you can write x plus 3 twice if it makes you feel better. You always need to check to see if that could be factored. In this case, it cannot be. So we're good to go for that problem. If it could be factored on the top, you would. Don't forget. Now these guys, this is where we would separate top and bottom. Now the top is already simplified, so this guy is good to go. That's our top. But we need to simplify the bottom. So the bottom, we have a negative 9 over x minus 3 plus 6. But we need to have a common denominator. So we need an x minus 3 multiplied to the top and bottom. And now we can simplify. So we have a negative 9 plus 6x minus 18, which simplifies to 6x minus 27 all over x minus 3. But of course we're not done. We can factor out a 3 here. And yes, you always leave this in factored form, because if you don't, you might not see when something can be simplified. So this is now the bottom. But then remember, to finish the problem, you have to do the top times the reciprocal of the bottom. So now we have 3 over x minus 3 times x minus 3 over 3 times 2x minus 9. And then we can cancel our x minus 3's. We can cancel our 3's, leaving us with 1 over 2x minus 9. Okay? There's nothing else we can do after that. So, moving right along. Solving. When we solve, there are two different styles of questions. There's one fraction on each side, or multiple fractions on a side. If we just have one fraction on each side, we can go back to old school cross multiplying. So 3 times x is 3x, and 3 times a negative 4 is a negative 12, equals, cross multiply the other way. Negative 4 times x is a negative 4x, and negative 4 times 2 is a negative 8. And now we just solve. So from here, we're just going to add our 4x and get 7x over here, add our 12 to the other side, and we're going to get 4. Divide both sides by 7, we get x equals 4/7, and we're good to go. But remember, you always need to check to make sure it's not an extraneous solution. So sometimes you list what your extraneous solutions could be. X is not allowed to equal a negative 2 or a positive 4. So in this case, none of them give us that, so we're good. If you want to continue with that train of thought, over here, x is not going to be allowed to equal a negative 4. But in this type of question, we can't cross multiply. So you need to get a common denominator for this entire problem. So we have a 5, and we have an x plus 4. So this needs the x plus 4 multiplied to the top and bottom. This one also needs the x plus 4 multiplied to the top and bottom. And this needs the 5 because it's missing a 5. So then you need to multiply and do all of that, combining like terms for the top, but the denominator goes away now for solving once you get everything. So x plus 4 times 2x minus 3 is going to give us 2x squared plus 5x minus 12, and that's equal to x times x plus 4 is going to give us x squared plus 4x. And of course, we have our 6 times 5 is 30. Get everything over to one side, so we're going to subtract everything this way, and we get x squared plus x minus 42 equals 0. Factor to x plus 7 and x minus 6. And that's going to give us x is equal to a negative 7 and a positive 6. And if you look, that is not one of our extraneous solutions, so both of those are good to go as well. Okay? So we're moving on to the last two questions, which are ridiculously simple. The only thing we're asking you here to do is list your domain and explain why there are restrictions. Well, in this one, x is not allowed to equal a negative 2 or a positive 4. And this one, x is not allowed to equal a negative a or a positive b. And the reason behind both of them is because your denominator is not allowed to equal 0. Okay? So that's it. I have stepped you through how to do just about every single question in this review packet. And I can pretty much tell you that if you understand how to do this packet, you should be golden on your final exam. That's it, y'all. This is Longo, and I'm out. See you, bye.